Thanks for having us. My name is Petter Kvist, work for a Swedish Proptech company called Saliar. So yeah, we'll get into what we're doing.
Yeah. And my name is Jonas Engstrand. I'm from Epishine, senior account executive there. And today we'll be talking about intelligent climate control for sustainable buildings. Beginning with Epishine. 37% of the global CO2 emissions comes from buildings today. To lower these emissions, we need to do something quite rapidly. Out of these 37%, 70% comes from operational emissions like lighting, HVAC systems, and so on. And this leads to that we need a digital transformation where we need to measure what's going on in the physical world. And to be able to measure, we need sensors and IoT devices. Recent numbers shows that by 2025, we will have around 150,000 new connected IoT devices per minute. If all of these devices are powered by batteries, this will lead to a huge number of batteries being both installed every year, but also goes to waste after 3 to 4 years as disposable batteries. If we play around with the thought that we will have 2 batteries in each of those devices, it ends up in 158 billion batteries per year. Imagine then having the need for maintenance and replacing all of these. It's not sustainable. So from our side at Epishine, we see that to be able to have a sustainable IoT, they need to be self-powered and powering electronics using indoor lights with Epishine solar cells. The benefits of light power, if you compare it to, for example, wired solutions and also battery-powered ones, is that you can cut the maintenance up to 100%. Instead of replacing batteries maybe 3 to 4 times over 10 years, you don't need to do that. And also the CO2 emissions that sprung from the power management systems of the device can be reduced by 85%. And you will have a device that will last for more than 10 years without any battery replacement. So to take with you from this is that you can actually, as a facility management company or a facility owner, you can lower your total cost of ownership a lot. And that's by cheaper installation. It's flexible. You can move it around. And you will also have a maintenance-free product. So these are some examples of where light powering can be used. It's specifically really good for retrofitting. Because if you have a existing building with wires and need to pull new wires, that is really expensive. So why not just use light powering instead? And to go over to Petter. So from data is not worth anything if it's not used. And that's where Saliar comes in.
Yes, can I have the...
Yeah, sure.
Is it possible to go back and forth with this?
Yeah.
So this one is... Perfect. So let's focus on how we can leverage this kind of IoT technology for energy optimization and decarbonizing the built environment. So basically, historically, we've seen a trade-off between air quality and energy efficiency. So either you have prioritized good indoor air quality and you've done that on behalf of the energy consumption, basically, or you have prioritized energy efficiency and you've done that on behalf of the air quality. So you get a lot of complaints from tenants. It's too hot, it's too cold, it's poor air quality, and so forth. And this is a big problem, and it's hard to balance these two very important aspects, of course, since air quality, of course, affects our health, well-being, and productivity. And of course, we need to reduce the energy consumption in buildings. So these are quite old problems that we actually can solve and get better at with new technology, new tech, such as Epishine and smart IoT applications. So let's focus on that, and that's what we're doing. So we provide a add-on service for existing buildings and existing BMS systems. So we integrate to old and new systems in order to stabilize the indoor air quality. So what we do is that we collect air quality data from these sensors every minute, and then we continuously calculate how we should adjust the ventilation systems, the heating systems, and the cooling system and so forth in the building in real time in order to maintain and stabilize the indoor climate, but also to, of course, save energy. So there's a lot of energy savings potentially by working with this type of solution. And in times where I saw this pop up in my LinkedIn feed, we are spending way too much on sustainability reporting. We're spending more on reporting than on actually doing things right now. And I thought that combining that and that we are living in a time where financing is expensive, it's hard to get like heavy capex projects. It's more important that we focus on the measures that provides a big impact, but does not necessarily require a lot of capex investments, so to speak. To be clear, I think solar panels, adding insulation, upgrading ventilation system, all of these measures are good measures. You need to do them as well, but there's a significant difference between the kind of solution and the kind of return of investment potential with these type of optimization solutions compared to these traditional measures that should make this more viable in these times. So thought I'd just share some quickly about a case from a customer of ours home in Sweden, where we integrated our solution to the existing systems in the retail place, so to speak. So this is 30,000 square meters. I think it is about 300,000 square feet, something like that. So in this case and in these buildings, we managed to reduce the energy consumption by 33%. We helped the customer to achieve a better ranking in their LEED certification by actually adding indoor air quality monitoring and making sure that we are maintaining a good indoor air quality for the tenants and visitors. And this, of course, results in major savings in CO2 emissions. And the payback period of this project was about 2 months. So that's an example of how it differs from traditional energy efficiency measures, basically. So yeah, that was what I had.
Good. And of course, combining these two technologies will improve your the green building status, so to say, even further. Yeah, thank you.
Thanks for having us. Of course.
If you have any questions, please shoot.
Thank you. That's a great presentation. Thank you, guys. Well prepared, and very, very interesting. I'm curious to ask, extending the use cases beyond the core value you've just demonstrated, around about alerts and alarms with building management systems, how you can preempt the complaint before it even occurs because you're monitoring in real time, and how we can kind of avert challenges with, the BMS set points by, immediately intercepting the change in value from your sensors.
Is the question for me or Petter?
Yeah, it's a good question. I think the problem with the perceived indoor climate is that it's very subjective. So it's often about it's too hot or it's too cold because we have different preferences. So, I mean, that is hard because we do have customers where we have one employee in a retail store, for instance, that complains about it being too hot, and another person in the same store might be complaining about it's too cold. So that is a struggle to balance. But what you can do with air quality monitoring is that you can educate tenants. You can show them because sometimes they might say, "Oh, it's poor air quality in our area," but usually it's just might be too hot. So then you can show them, if you're monitoring, we actually have a good indoor air quality. The temperature, it is what it is sometimes, but by monitoring you can gain better control. And by acting on it in real time, you often manage to stabilize that temperature.
And I also think that you can educate the occupants as well and tenants that if you lower your indoor temperature by this much, you will save this much for the building, maybe decrease the rent and so on. So yeah, I think it's a lot of in change management as well. And that's
Thanks. Out of interest, do you notice any different in temperature for genders? So I know that I've seen some studies that women typically prefer it a couple of degrees warmer. Do you have any studies surrounding that? And is that true?
Yeah, that's in general. I don't know the exact study, but in general, you have women prefer. I think it's 1.5 degrees warmer or so. But then it's very individual. It varies a lot between ages and so forth. So it's very individual, I would say. But yeah, I went to a site visit as the customer a couple of weeks ago, and then we went into the store. It's a retail unit in Stockholm in Sweden, and we went in the store, and it was like, I think it was 18 degrees in there. It was so cold. We were freezing when we went in. And then there was an employee there. She was sweating and saying, "Oh, it's too hot. It's too hot." So, I mean, it is hard because it's very subjective, but you can handle a lot of these problems by actually monitoring and making sure that you are controlling the HVAC system, the heating system, ventilation system in a smart way.
but it's true in my home at least. So any more questions? Thank you.
Thank you.